All right, welcome to the next video for Chapter 4, Section 2, Symmetries. And I want to try something new. I've never actually done this before, but there's always a certain time to take appropriate risks. And if it doesn't go well, I can always delete this video, but I have a feeling it's going to go pretty well. This is the 21st century. We're using technology. Of course, we need to know, how to do it on paper for some of the things, but we should also kind of know how, like, the basics of these programs that one day we might be using, or really similar programs. So let's all go to Desmos. You're going to do this with me, or at least watch me do it and then practice on your own, because remember, perfect practice makes perfect. Okay, so my screen's over here, even though my camera's right there. I'm going to share with you my Desmos screen, so you should see it, right? And we are on page 183 in the textbook. And this is really where, if you've been not looking at your textbook when you've been watching these videos or in class, it's really going to hurt you. You want to have your textbook open, because I'm not writing anything down. All right, you should, but I'm not going to. So it says the vertices of triangle JKL are 1, 3, 4, 4, and 3, 1, JKL. So to get that, kids, if you've never done the table before, now, can we picture this? This is a triangle. I can't figure out how to connect the dots. And you know what? Maybe a student of mine will tell me one day. But this is a triangle, JKL, all right? And we want to do certain things. So you're going to add a table, okay? Now I'm going to move this one down here. So in green is my original function, number 5 on page 183. Now you should probably type in triangle JKL. Now the reason why I want to do this on the computer is because in the past, when we do it by hand, which really is a good thing to do because you can kind of intuit it and visualize it, you lose the appreciation for what you're just doing to the numbers. So I want us to actually follow that core concept on page 183 and learn to read it, learn to read these types of math sentences. So we're going to graph JKL in green and its image after a reflection in the x-axis. Again, I'm following my textbook. That's what I'm looking down at. So let's look at the core concept. If AB is reflected in the x-axis, then its image is A negative B. What changed? What changed? AB became A negative B. We just changed the sign on the y value, on the B, right? So let's change the sign on y and let's visually look. Do we agree? Does this reflect it over the x-axis? So 1, negative 3. Okay, all right, maybe, yeah, maybe 4, negative 4, and 3, negative 1. Okay, now let's zoom in and then out a little bit. Okay, so here's my original triangle by these 3 green points. Does this blue triangle, J prime, K prime, L prime, technically, does this look like the reflection, the image of JKL after it is reflected over the x-axis? So let's go out so that every box is 1. There we go. So this point is 1 away from 1 above the x-axis. So its image should be 1 below the x-axis, reflected over the x-axis. This point is 1, 2, 3, 4 above. So its image should be 4 below. Likewise, this point is 3 above and its image should be 3 below. So there's your answer for number 5. Go ahead and copy down those points. If you want the practice graphing on by hand, you should practice then. So go ahead and do it and come back and we'll be ready. I'm going to turn off number 5. See what I did? On, off, on, off. And we're going to add another table. And this will be number 6, but I'm going to drag it right here. This was number 5. This will be number 6 right below. It's going to be in black. And it's going to be triangle JKL and its image. Okay, so triangle is going to be the image after a reflection in the y-axis, over the y-axis. So let's look at the core concept in the middle of page 183. If AB is reflected in the y-axis, then its image is point negative a comma b, negative a, b. So stop, what changed? AB became negative AB. AB became negative AB. Just the x value changed signs. So let's see. Remember, we're looking at our original JKL right here. Let's change the x values. Negative, why do my fingers go to the wrong keys? Negative 1, 3, looks good so far. Negative 4, 4, and negative 3, 1. So here's our y-axis. J is 1 unit to the right of the y-axis, so its image, J prime, should be 1 unit to the left. K is 4 units to the right of the y-axis, so its image, K prime, should be 4 units to the left. And L is 3 to the right, L prime should be 3 to the left. Cool? All right, let's get a little tricky here. Let's see if we can apply the core concept, the rules. Read the math. Math is a language, read the math. And see if we can reflect it over y equals x. Now, might be a long time since you've seen y equals x. So I'm going to go ahead and turn this off. You should rewind, get those numbers again if you didn't get them so far. Turn that off. And I'm going to go ahead and type in, oops, y equals x. It's hard to type on my keyboard when I have to reach over my textbook to get to it. All right, let's put things together. So here's our original JKL. All right, remember original JKL. I turned off number 5. I turned off number 6. And number 7 says that we're going to graph JKL, boom, and its image after reflection in the line y equals x. Okay, so this red line right here is my mirror. It's my line of reflection. So let's go ahead and add a table. Oh, it added right there. Why is it in green? I don't want it to be in green. Let's see if I can get a. There we go. Ooh, red kind of goes there. So what is the rule for a reflection in y equals x? Let's take a look. If AB is reflected in line y equals x, then its image is the point BA. If AB is reflected in the line y equals x, its image is BA. What happened? That's it. X becomes y and y becomes x. Cool. So 1, 3 becomes 3, 1. 4, 4 becomes 4, 4. I wonder why. And then finally, 3, 1 becomes 1. Now watch what happens if you missed it for the first point. Sorry. Did we switch x and y? Does this triangle look like its own reflection? I mean, that's what we're saying, right? If it went right on top, is it its own reflection over y equals x? Mathematically, it is. To me, it looks a little off, and that might be Desmos, because I think the boxes for the x values are wider than the 1 unit on the y-axis, which is a legal thing to do. You can, as long as you're consistent in any dimension, the horizontal dimension or the vertical, it doesn't matter. But mathematically, though, we did it right. So that's awesome. Just in case, original, switch the x and the y, the a and the b. 1, 3 becomes 3, 1, 4, 4 stays 4, 4, and 3, 1 becomes 1, 3. Boom. It's its own reflection over y equals x. But is it its own reflection over y equals negative x? Let's find out. Okay, there's y equals negative x, right? Negative slope, top left, bottom right, negative line. So I'm keeping the same color. What are the rules for, and I'll delete just so you know this is a new problem. What does the core concept say for what we should do if we're going to reflect over y equals negative x? Let's look at the last line. Let's read the math. If AB is reflected in line y equals negative x, then its image is the point negative b, negative a. 2 things happened. What 2 things? AB becomes negative b, negative a. So we flip a and b, and we change the signs. We flip a and b, and we change the signs. So we flip x and y. So 3, 1, 4, 4, 1, 3, and it's nice that it's a computer. We also change all the signs. Does this red triangle look like a reflection over y equals negative x? Yeah, it does. It's a little distorted because of what we talked about in the previous problem, but that doesn't mean that we're mathematically wrong. When we draw, is it going to be drawn perfectly? No. You know, yeah, the graph paper is probably lined up perfectly, but that doesn't mean our drawings will be. So there you go. We can read the math. Yes, we can draw. Yes, we can intuit from our drawings. But can we also learn to read the math, apply it, and then make sense of it? Confirm with our eyes that it works. Yeah, we can. So that was page 183, numbers 5 through 8. You're going to have problems to do on this, but I do want you to take now a look at lines of symmetry on page 185. We'll talk about the rest together.